Here it is. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers, language runtimes, implementations, types, whatever, and whether or not you should use AI when you're building your compiler. So a lot of that been going around, discussions here, work, elsewhere. It's all good. Um, yeah, I was going to show something about, well, okay, so we're all being recorded. We show up on Zoom. I start up on YouTube in a few hours, maybe. And no real set agenda. Today I'm going to do some short, simple demos. Um, and then next 2 weeks, I'm off for Burning Man, and Theodore says he'll try and see if he can get them to go, coffee clubs. And then maybe we have a guest talking about Pony the week after that. And then I'm gone again the week after that, although I think I'll be at the airport at the time that CCC would be going on, and I don't want to try and host a CCC while I'm sitting in an airport lobby.
Maybe you can join. I will host it
I
and
might be able to join if you set up. Yeah,
yeah,
that would work.
yeah.
Here's Mark, in fact. There we go. And so let me go do demo things. I haven't prepared really a demo, so I don't have a nice, slick, smooth path here. I have various bad paths. I'm trying to figure out which of the bad paths is the correct one to go with here. Let me go with Emacs, and then I'll be running in IntelliJ and be swapping back and forth. Uh, so like my one of my goals here was to have uh, a hello world be a one-liner. The return is optional. If you don't put a return in, you would get the return value of print, which would be the length of the string printed, which is like 13. Yeah. Um, so this code looks up sys, which it gets from the command line arguments, which I could cut and paste here really quick to show what kinds of things, if I can find it. Now I have way too many windows open, though. Finding it, the one is a bitch. Yeah, no, 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 no. Okay, how about this? See if this will let me paste in here. Yeah, okay, so this is like a standard command line argument here. It's like Java, I need the Java libs things that you would put into a jar. You can run this from a jar. I call a simple driver. He takes a dash L and has a directory where the sys library exists. That's the only symbol that starts with a lookup, anything on the dash L line here. So I don't have to let me get Cameron in. I don't have to import sys if it shows up on the dash L command line here. And the doc examples of a hello world, the examples of a bunch of things in them. So I just wanted one that was, going to be first if you looked at the examples. So that's the launch line that builds and runs hello world. I wonder if I could. All right, this has been working on and off, but there's all kinds of environmental issues. So this may or may not work here. Oh, let's kill that. We'll make one go and see what happens here. Nope. Try again. Like I said, I didn't have anything prepared. Oh, Zoom is like messing with me here. Okay, so that compiles and builds, but it pulls up the sys library, which is in source main sys. Yes, why are you giving me issues here? Simple. That's why. Okay, so here is the layout of the main sys library module. It has a sys guy who is simply listing as local variables a set of names which he will now look up adjacent and one level under. So the general module system here is you've declared a module because you put it on the dash L line, it finds the module there. A module is a normal simple class file, which these are all normal simple class files. They have no instances of sys, but there's a class for sys. So these are global class variables. ADT, array, array I64, these are global class variables. And the names after them are looked up in the normal namespace, which means I go down one layer from sys and I find them all. So in here are things like IO. Okay, what the hell does IO look like? IO is recursively the same module. It's the same thing. So there's a print as a global in IO. So up here then, sys was found because it was a module name that was found on this dash L line for the compile. Loaded as a simple class. It has a bunch of global variables in the sys, which would be IO is one of them. IO was done the same way. It was found in the dash L. It gets loaded the same way. It has a P as a field. The P is a function type. The function takes a thing cleverly named string, but it's actually a constant U8 array. Converts it to a pointer, calls libc write with the length of the string and standard out. And then libc here is found the same way, and he just has foreign bindings for write with the equals C equals. So there's a lot of complicated shit going on, but you can write hello world by just saying sys io print and a string, and you get hello world. And here's bubble sort back, thank you, which I'm going to start down at main. So if you included a main, you get it. And if you don't include a main, you get the default your class code in the CL init. The starting code I wrote where sysio print, that would be your main. It runs your class initializer. And so main then has a local variable usage, which gives you a usage string and gets out. So this is an anonymous function just put in a local variable. Then he starts doing checks for sanity on the arguments. You have two arguments. The zero argument is the self process, the bubble sort exe, and the one argument has to be a quoted string of a certain format. I then parse that string. If that fails to parse, then I give you usage. And then if it's too short, I give you usage. Then I call bubble sort. And then because bar nums here, nums is a sys array I64, that's a vector Java array list of a primitive longs or a vector of longs or whatever you want to do it, how you want to call it. He understands how to convert himself to a string. And then the string is actually the array U8, which is again a mutable array of a resizable array of 8 byte things. Oh, my cat is coming to die. He's complaining his world is ending. And then so I can add a new line and call write on it. So I'm going to look here at sort for a second. He takes this mutable resizable array of nums. He sets a Boolean flag for whether or not he should go on, and then he walks the array and does the check and does a swap on elements and says, "Oh, I swapped, so I have to go more." And that's your standard bubble sort. Repeat a complete sweep over the array, swapping wrong direction elements until you get it sort done. And then he prints the thing and he's done. All kinds of other things in here. Let's go look at array U8. Standard library has an array. The array is mutable. That's the bang. It has a length. You must call the constructor because this is not nullable. So upon creating a new array U8, you have to some work has to be done to make it a not null value. And the null checking is all baked into the language directly. So you can never throw a null pointer exception in any of this stuff because he always null checks as he goes. Usual things for like here's grow by one and add a character. And the return on self just lets me flow code them, chain them together. Add another string, add an array, undo some characters because it's just a builder, add a number, write to standard out or standard whatever file descriptor you're given. I added a parser that given a plain array, not a variable one here, it just does the same thing as a C A to I. What else?
So, so where's your new implementation?
The new implementation is a baked in. So that's not written in the language itself.
Is it in is this running in like native code or is this running in
This
Java?
is running, I'm compiling all the way out to native code. So let's go do that. So
So is it just like calling Win32's like virtual alloc or like what's going on there?
I'm calling C's alloc, malloc. Um, so the generated code is for hello world is push the stack. Everyone gets this pointer in all situations for every call. This is your CL init for hello world. So that's junk in this particular case, which could be optimized. I haven't got around to it. Load the string, load the length of the string, load standard out, add 4 to skip the length. So the string here is 13 is the length, and the first 4 characters are the length, and then the actual hello world characters are here. So obj dump's not doing me any favors. And then he calls write. So that's a direct call to write. So if I look
Wait,
at the
why
hello
is
world
there
guy, go ahead.
I was gonna ask why your constant pool is being disassembled. Did you set the section flags?
Oh, I almost surely, yeah, don't have it labeled correctly. I labeled it as RO data. So now what should I put here that would have it disassemble as a string or print as a string? It's fine.
Well, it's listed as data in the section listings, I think. I
I could
see
move it.
LD.
Yeah, I could
It's
move it
not
to data.
like it's named. That's the normal name, but I think it's tagged as being instructions.
Right, it's right. I understand that it's disassembling for object. I'm not super excited about why that is or what I would do about that.
Yeah, it's got the executable bit set.
Right.
Um,
Okay. Yeah. What was I going to do here? I was going to say, yeah. So I have optimized by inlining print. So this becomes a field load of sys or production of sys from first principles from the dash L on the command line. That gives me a CL in it, a class structure for sys. Load up the IO field, which gives me another class structure for the IO struct. Load up the P field, which gives me a function, which takes a string. So that's all, those loads are done. The inlining is done. If I go to IO, then this guy inlines, he does the conversion from a pointer to an int. He then inlines all that stuff and it goes. So that's what happens there. Let's go look at bubble sort. I don't know if we, oops, probably can't do that. I have to do, how about this? Let's see here. Bunch of strings. We scroll up. Here's sort. So no stack things, move something around, load from 8 bytes in, decrement count. Where's the jump? Sort to plus 19. That didn't help me any. 149 to here.
I found a link that might be useful. I'm not super familiar with COM, but
I'm sorry, what might be useful?
this link is I put it in the doc. It seems like they have some information on the COM format, PE like PE
Oh,
read, write, executable stuff. I don't know what the hell works, but
well, all I'm showing here is that I have some reasonable code here for doing the run. I mean, for running a code here. Here's like inner loop where he does the swap, right? And where does that go to 149 up here? And he has the test for exit or not. And then he runs through the I didn't find it. Ah, here we go. This is the code that says I don't actually do anything because they're in order. And here's the swap. So I don't know. That's reasonable bubble sort code. No unrolling, no special things going on. Everything else is set up for main, which has like God only knows some of these are inline and some not. Here's a call to Cicerary string printing. Here's the call to sort. So those didn't inline, but the other things inlined in bubble sort. So that function was just hung off to the side. There's no more inlining. So this is probably not. Oh, I don't know if that surely didn't get inlined. It might have gotten inlined. Uh, Here's the parse array is big. Compare, compare, compare. Here's a compare. Where does this jump to? Jumps to,
Yeah, it appears to be your compare because it's two.
and here's the right. Okay, so the usage got inlined and is at one point. And he is maybe this is the entry point. I'm sorry, this is the one right that says I didn't like you for whatever reason. This test was this fail out, and then he calls parse array. He only get one necessary fail out. Seems odd. What did I do with bubble sort? He says args were two. Oh, and then he does Cicerary parsing, and then he has two more tests. So that's correct. Here's the parsing. Here's the next fail, goes to E9. Down here at E9 is going to be some other string. So he loads standard out, where the string is, the length of the string, calls the right call, and then jumps to 115, which unwinds and gets out. So yeah, this is like reasonable code. Nothing special, but nothing bad either. Um,
Pretty good.
yeah, thank you. Let me see here if it'll actually run. I've been having issues with setup here on
So
different.
based on the fact that you're running Java, I'm assuming the compiler itself is written in Java
Yeah,
or
it's all
Kotlin.
written in Java. That's right, including outputting all the machine code and everything else.
I guess that's one way to have a very cross-platform compiler.
Let's see if I. No, I have some usage error thing. This is working in my test cases in IntelliJ, but not from the command line, so I need to sort on that.
Well, there's
But
an extra space. Get rid of the extra space before the two.
it shouldn't matter. The theory says I'm completely white space tolerant. Yeah. Okay, so I'll do that because I want to show that it does work. So let me stop the share and then come back to IntelliJ and share. If I can
List
go
these two integers.
find it in my 1,000 open windows, that looks like IntelliJ, maybe, which is now too small to be seen.
Oh, also, did you see the kind of the draft for the virtual machine that I posted? Do you
Not
think
you posted it in
in the Discord?
Discord a
Yeah.
while ago then, because
Yeah, yeah. It's
no, because I don't recall. I mean, I did. I glanced. I didn't look at it anymore. Well, here's test bubbles going to run, but all he's going to do is sort like this set of things and or this set of things. This is the answer. So I know it works. Okay, fine. So I had issues with my argument parsing there. Let me go do. Let me. Darn it. Let me go get. Oh, and what is chat? It's everywhere. Oh, and Theodore's already out because he has his guest. And there's your chat. Okay, so somebody needs to take over docs, and your link there, Ryan, should go into the docs.
I put it in there. It's in the section one.
Okay, let me do
Yeah.
Emacs again, and I'll do two more test cases to look at what it looks like. Uh, yes. What do we got here? Oh, let's look at capitalize is like another minimalist example. And then we'll look at Dijkstra, which is a little more exciting. This one is just supposed to be capital is first letter of a string. So you have to have a string. And if I don't see one or it's length 0, I complain at you. And then I go ahead and make a new string and I copy it from the old one with one extra character so I can put a new line on the end. And I have a car to upper just for this test case, and that's it. It's nothing special, but it's also not terrible either. It's just like C code, almost kind of sorta, with news sprinkled in. And the other one is Dijkstra, which is trying to do a much more complicated thing, doing a shortest path algorithm. He has more setup code. Give me a bunch of args, parse a matrix, decide it's not empty, decide all numbers in it are positive, decide that it's a square matrix. I don't have a square root for integers, get a source and a dest node, then call find the shortest path and print the shortest path. And the shortest path algorithm is kind of reasonable here. I don't have an integer minimum max int, but I need to group the integer utilities in some place and get a max int. Set the distance to max int and the starting point at 0, and then walk all the nodes and find the one that has the best distance so far, which will be source. And then once you have it, decide this is how far the nearest guy is, and then you have to go walk everybody and take the edge weight and add it and pick the shortest edge for the next dude. And that gives you a moving wavefront of nodes that have been has their cost uh, set, but they've not been visited. And so you find the next best guy to go visit, this next shortest guy to go visit, and then having visited him, you discover his new cost, and you apply that cost to the expanding wave of guys until you hit the dest, and then you're done and you get out. So, it's just plain old, but it's also generating directly code and working. So, and I don't have to have any imports at the top of things. He finds all the bits and pieces. So that was it. That was my simple update.
It's impressive. Every time I see someone write a backend, I I think that's the most complicated part of a compiler for
Oh
sure.
man, for me it's been types. The backend, but I've done the backend too many times in the past, maybe. So I have a backend, and it does, loop invariant code motion and all kind of constant propagation, constant folding. The nullness thing comes out of the types is also just exactly constant prop. But then it goes into machine instruction selection and basic block
I,
layout and register allocation, scheduling, elf
I think
file writing.
types for me is easy, but I think my compiler design is very different from yours
Yeah.
because I use a bunch of coroutines and recursive queries that are.
Oh, yeah. Yeah, theory says I could make this compiler very fast. It's reasonably fast and has a lot of really stupid things I'm doing to make it easy to read, look at, but it can be made a lot faster. So that part was kind of, I gave up on compilation speed directly, but there's nothing in there that's inherently must be slow.
Could you talk a little bit more about some of the later stages of your backend? I'm kind of jealous of your code quality for that like bubble sort. It's very slick. But also just in general, like,
Thank you.
how like I think we've talked about this at some prior CCC, but it was a while ago. Like, do you have like an LIR like where you lower to after like register allocation or something? Like how does that like end of
Yeah.
the stage
Yeah.
or
Yeah.
end of the pipeline work?
Right. Yeah, right. Okay. Okay. Zoom light though. Thank you. Cogen. That's the main driver. Here are the passes. Parse, iter, early peoples cleaning things out, a more aggressive analysis of it's a sparse conditional constant propagation, but with a very rich lattice. That does all my type checking as well as optimizations. Then type check just verifies that I have no type errors. He asks everybody if they have all agreeable arguments, and if they don't, you get a type error message. Build your loop tree. Uh, Unlink and serialize are there to part of the typing things I'm doing is I build a call graph as part of sparse conditional constant propagation, which lets me do much stronger optimizations in and around Well, just in general, I have a real serious call graph, and I can turn that into inlining, very specialized inlining things, or just carry values in and across call sites directly. I remove the graph shape that carries the call graph. So the call graph's embedded directly in the standard same IR that everyone's using. I just remove the edges. And then serialize is where I dump out to an ELF file the serialized IR. So I'm done with the IR at that point for its semantic meaning. So I dump that out, and later when I'm doing parsing, I will read in the sys library's serialized format, not machine, so idealized node still, but it has full type info and the full IR, so I can do inlining, all kind of shit there. Fine. Another round of unlink for other reasons, and then select. So this is where you would say lowering. It's the same nodes, but they're machine specific. So if I go over here to simple and look at my hierarchy of uh, layout here at the top here, source machine simple. So CodeGen is its own pile of algorithms that do backend things. Here are the nodes, and there's a bazillion. Like an add is just exactly what you expect. Add two ints, casting nodes, converting types, dividing, and then some weird ones like escape values, which means I lost track of you I lost my escape analysis. So I have a basic escape analysis baked in. Function nodes and function pointers and blah blah blah. Okay, here's CPUs. CPUs have just the machine specific x86. So these are standard nodes. Just go look at like add immediate as an x86 node. Oh,
So you're
and here
targeting
it's
V2.
I'm sorry?
You're targeting V2
Yeah.
specifically.
You could add another target by just changing the name and I class for name those. So you wanted to add another target, you make a directory, give it a unique name, and you class for name it when you launch the code generator saying this string, target it. So I can cross compile, or I am cross compiling ARM and RISC. It's all fine. So, so what's an immediate x86? Well, it's a mock concrete node, implements mock node, and it has all the x86 immediate things, which is mostly encodings. So this is a standard node. So let's go at mock concrete node.
Yeah, it makes sense. I think like so
It's
I have
just
sort of two follow-up questions about the design of this. Or I guess one of them is just to confirm, like, so this means that if you have any kind of like, you know, legalization that you have to do, like let's say you have a constant that's too big to encode as an immediate,
yeah,
or like,
yeah,
some other complex addressing mode. So this is where you lower all that, which I guess makes sense.
yes. So
Um,
in RISC like does that directly, right? x86 takes fat things. So here's RISC. So somewhere in here is the RISC V main dude, and you want here is the instruction select guy, which takes an ideal node on the left and produces a machine-specific version on the right. So if I look at constant node, he calls the little con helper. Yep, yep. The little con helper says things like, well, okay, if you're not a constant,
yeah,
you're a
yeah.
specially thing, whatever, your type integer. If you're known to be something small, I'm going to give you, if you're 12 bits, oh no, God, you're terrible, you're big. So you fail the big check. So now I output a stacked series of RISC ops, a load upper integer and an add I RISC.
But is this like arrows in the switch statement? Has Java always had that?
Yeah,
That's like
Java's
new
had it.
Java. I think
Good.
it's at least I think like 4 or 5 years old.
Yeah. Like
Okay.
I want to say Java
Okay.
21.
I'm super out of date, man. I haven't used Java in ages.
So
Like I
in
think
this kind of a thing where you just arrow and return, it's like really nice looking.
Yeah, yeah, I think or I mean it is both a good Java feature and also I think, this constant lowering makes a lot of sense. Like I've written the same logic for my RISC-V backend and it was equally kind of annoying. Um
Right.
because
Yeah.
RISC-V is
Here's
just
the
kind of like
one
that.
for
But
compare, which
yeah, yeah.
has set immediate or set this or XOR before set or subtract before you set, right?
I guess out of
Because
curiosity, how are your branches? Because that was the one that really was like in the pessimistic case, it sucked really hard in
on
RISC-V for me, I
x86
think.
or RISC here,
for a RISC-V, because x86 it's like fine pretty much, but like I
Yeah.
remember
Yeah. Okay.
I guess because you maybe are emitting the compare separately.
I emit the compare separately, but different
Right, right.
guys have different places where they peek around and see they're doing a compare branch, and will do different things accordingly.
Yeah, yeah, it makes sense. In my compiler, I guess it's probably a little nicer because you still have this like node representation. In my compiler, I go straight to the macro assembler, and so like
Ah,
sometimes pessimistically before linking and branch compacting, like a jump in RISC-V or a compare and branch in RISC-V, which I try to represent as one macro assembler instruction, ends up being
right.
like 8 instructions because it's like you
Because it's a
materialize like a
bad
big
case.
constant
Yeah.
and like you have to do
Yeah.
an indirect branch like because you can't encode the branch offset theoretically, all this nasty stuff.
Right.
Anyway, the more the question I'm not sure of that I'm curious what you're doing is so it seems like you're doing this like CPU specific lowering before something like register allocation,
Yep.
which is probably the right move. But does that also mean that your register allocation needs to be aware of system specific operations, like if you do a spill?
Yes, it
Okay,
does.
so in your register allocator, do you have like a switch on platform or something, and you emit
No,
different
no, 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 no,
variants?
no, 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 no. No, you go to mock no. Just click when you mock, it's going to be the interface. So every machine description has this interface it must honor, describe. Um, every node has a register map for inputs and outputs, and kills for flags on x86, whether you're a two-adder and or whether I can commute you, and whether you're copy or cloning and blah blah blah. And where is the spill? So are they done for each one? They might be done for each guy. There's a way to get oh, where the allocator calls a generic, give me a spill.
Okay,
Have the
and then
allocator even
that
loaded today? I
is
do.
responsible for emitting this loads and stores. I would assume.
I do splits, um, not loads and stores.
Well, something eventually has to like take one of those split live ranges and put it on the stack, right? Like if you're out of registers.
Uh, trying to figure out where I hit it. Split node. Where is split node today? Oh, it's just a normal node. Oh, that's why. Okay, so I have a split node is a node which takes any scalar value in any location and puts it in any location. And that means it'll go it'll do stack to register, register to stack, reg to reg, stack to stack, and the very rare cases that you need it in which it encodes is a horrible thing. Everybody has one here. Let's go to the risk guy.
Does it reserve like a special register for that, or is it?
No,
I
no,
guess
no. If you
probably what
do,
you do is you can like push a random one.
yeah, right. You do something
Okay.
horrible if it's reg to reg, which the allocator never does that unless it's excruciatingly terrible. So here is the encoding. This is all split reg is the RISC version. So the standard instruction selection doesn't have to deal with splits because they're not input except by the allocator. But the allocator will go ask for the machine specific version of a split node, and you'll get a RISC version, which has the encodings. And the encodings say shit like, oh, you went to go to this. There's a stack move. It's not even implemented on RISC because I don't see it. You have
Mhm.
to try really hard to get the allocator to suffer that one. Otherwise, you just did looks like a load here. And so he's deciding it's a floating point load or whatever. And he's coming from a stack using compute stack offset, which takes whatever the allocators decided how things go. So uh, all the notion of a split, which splits a live range in two, I guess you can't see my hands, I'm waving them around. Um, then the two halves of the split color differently. And if they color to the stack or they color to a register, you get a load or a store or a reg move. So he has, all the different flavors.
I have a question about optimization, whether this is like feasible. So I'm not like a backend guy, unfortunately. So I don't even know if this would make sense to do at all. But I had this idea of like, let's say I have two different ways of implementing the same code. You know, you can write code that does the same thing, right?
Hmm.
So what if I said like pick A and then it's like else B, right? And so you have two different code paths. And all
Hmm.
that's saying is, hey, compiler, pick whichever one of these two you think is going to be faster, and you could pick either of them. And like from a language standpoint, it could just be random. But what I actually wanted to do is I want the compiler to like guesstimate once it's
Oh,
optimized each path, like how long each one's going to take or which one's using less registers or whatever, and decide which path to take.
right. Um, so C2 went through variations of that. Nothing like that directly. He went through several variations that are nearby. So if the user had like the x86 had at the time of C2 early and now even more had a bunch of varieties of code gen for the backends. And they mostly ask the question, are you this version? Are you that version? Are you whatever version? Like, he's a jet, he's runtime, so he gets the exact CPU type. Then he would change uh, instruction patterns at the ideal step for like how to do min and max as a conditional move, or there's a special op, or you did it just a compare and jump. And that was one place early on. And then in instruction selection, he would again choose different instructions based on x86 version numbers. Um, and then, the scheduler all knew about weights of time for things or where they used various resources. Like it's a functional unit aware scheduler in C2. So he would pack instruction selection differently, some reg allocation choices differently. So all things that are customizing it for one particular version of x86 versus another, but not one that said I have a interesting pattern and I want to expand it one of several ways based on the target chip. We didn't do
Yeah.
that unless we just knew, oh, we know it's this. And so the pattern is you always take this version versus that version. Yeah.
Okay, I was just wondering if it's like even feasible to do, or if it would make sense, or if it'd be like, okay, yeah, that's gonna make, a combinatorial explosion of compiler
I,
complexity, and it's not worth doing.
no, I think you're thinking about it a little the wrong way. You would write the snippet, and the compiler should go compile the snippets in its best guess estimator, what he thinks how they're going to be called in what context, because it would change how the code gets generated always, right? And then come up with a guess of which one's cheaper for this particular platform, and then squirrel that knowledge away. Separately, now when you invoke this chosen pick one pattern, he compiler's already gotten a cost model for them both. He looks at the CPU, looks at the cost model, picks the pattern early on, way before anything else, and throws it in. Done. Throws it in the parse or the early stages of things, and then let it flow through from there.
Yeah, I was thinking even just like ahead of time compiled, like pick, like
Yeah,
not even like
that's what I'm saying. Ahead of
uh
time, pick which one. Do the cost modeling up front ahead of time on your targets. Pick a number. Don't be doing it on the fly while you're compiling other things, because it's just taking time that you could have done earlier. David, did you get your questions answered about what's going on here?
Yeah, yeah. No, this makes a lot of sense. I think it's a very logical way to approach it. I've been kind of in the pits of my own like lowering step because I think I made a mistake a while ago in terms of for my backend, my thought was, oh, well, I'll try to keep the like platform specific code as like, I want the surface of that to be as small as possible. And so
Yeah.
in mine, I do register allocation before instruction selection, and even the instruction selection is kind of a
Mm.
proxy for like it's kind of this abstract like it basically feeds into my macro assembler, and so the macro assembler has some additional like so there's already like I do register allocation at first, and then when I do instruction selection, I then have to do all these like, because instruction selection can add additional instructions. It might require an extra register or something. And so I need to like reserve scratch registers for that, and that just ends up being super wasteful. Um, so I've been trying to think of like what's the best way to get out to avoid all that. Um, Which it seems like probably what I need to do is just bite the bullet and add a bunch of, machine specific instructions, or at least like some sort of machine specific lowering so that like complicated opcodes get, lowered in advance of register allocation. And then it should just be handled fine.
And then it goes from there.
Basically
Yes.
what you've got here.
Yeah, this is my what it takes to be a machine. A name, a set of registers, how to make a split. This gives you the machine specific split from a idealized split, which is what the regal's using to get a split out of it. Caller saves, callee never saves, are masks, returns, and return masks. These are how you calling conventions where your
Yeah.
return is, including on an x86. It's on the stack already. Unconditional jump, all the instruction, basic block layout guys have to insert occasionally unconditional jumps because they can't get a perfect layout. And then the instruction selection call, which is the big one. And then the regalloc has this fancy math, which is C2's used it for 25 years. It does a good thing. So you ran things in registers until you ran out, and then you ran things in whatever your arg slots go on the stack as you're passing them. And then the called target needs to have some space for outgoing args for the same problem, plus his own internal spills, plus whatever alignment things happen. So that the regalloc starts with a uniform numbering space for stack slots that looks like this. And there's
Hmm.
a twist where he moves the things that are up here down below, or the things that are down here up above. He gets the twist example somewhere down here in my post warp numbering means I shuffled the high half to the low, but I wanted to allocate in order, so I don't really care. So these things here all are guaranteed by the signature of the called guy. And then I don't know how big the spills go because that's how much spilling I have to do. And then this is all guaranteed by the outgoing calls, which I will get at the same time I'm getting the spills because I'm watching how they go. So I end up with this set of stack slots, but the low numbers are intended to be incoming args, and the high
Hmm.
numbers are outgoing args, and spills are in the middle. And that means incoming args are actually at the maximum stack slot after you've moved the stack pointer, and the other ones are the other way. Anyhow, there's a split in the middle where I have to do weird math. So the register allocator is full of these funny things where they say, hey, I'm going to have some machine specific hacks for this, but they're kind of ugly looking on some chips or another. Let's see, what was the name of that guy? That was Max Arg Slot. Yeah, this guy. Do I have a hidden self arg? Count how many args, count how many floats, count how many ints. Oh, I have a count of 8 ints or 8 floats. And if you failed out, then you got like you went to the stack or you didn't. So that's piece of it. And then you get this other stuff here where I'm like, okay, look at your calling mask. What are the input args? Do you have any? Where are they at? Okay, count the hidden one. Uh, get my signature lined up. Okay, now the floats go in the float registers, and I start returning you reg masks that are in the float space, or C args, which varies according to whether you're using one of two different calling conventions as to which flavor of set of in args you're using, or you ran off the end and I gave you a stack slot, or you went way, way off the end and then I have a to do here. Anyhow,
I see.
the register math is it's not rocket science, but it's way detailed oriented. But if you do that, then your description of what it means to be a machine can have this nice sort of pattern where it just, let me go back to the RISC, I'll show you that guy, of where
Like
he
every target can
describes.
talk about the frame the same way.
Yeah, so I'm talking about the frame here. So I just have a list of registers. They have fun names. They have the pretty printing names and some more useful ones. And then I have just pile of bits. All my register masks are piles of bits, unless you got two into the stack, and then you get the fearsome -1, which is and all the rest. And then the arguments are directly usable and nameable, and their calling conventions can name them directly. And then I'm into opcodes. So this run of several paragraphs is how I describe the register masks in a machine independent way. And the
Yeah,
x86 has the more
I actually do
complicated
mostly the
version.
same stuff. Like, I have this like, per machine, I have like, I can ask it for like, give me all the caller saves as like a bitboard or something.
Yeah,
And I can order them together, I can iterate them, etc.
yeah.
Um, the main thing I'm just missing is I think I don't have I've avoided any platform specific instructions. And so everything has to get
Ah,
lowered to these still kind of abstract instructions. And
right.
then the macro assembler has to take on a little bit. Like after all of my other optimizations, the macro assembler then has to do a little bit of extra stuff of like, final instruction selection. And it just ends up being kind of a pain. Um, so I think, you have a more extensible system, and I might try to move more towards that.
Ah,
Um,
okay. Yeah, I was looking at like in my world, an ad node as an ideal guy uh has a bunch of things where he settles on this is generic ad that does both ints and floats. And he has to decide, is he talking about ints or floats? So there's some typing going on
mhm.
in here. And then he has some optimizations for ads where he does all kinds of re-canonicalization for, especially on addressing math. But he doesn't do any machine specific thing here. This is all addressing math layout things where you do left splines of stacked ads so you can pull all the constants or whatever the hell. A lot of things.
Yeah, yeah.
And then I
Which
have
I think
a,
the main, like the divergence point in my compiler is I can take my equivalent of this ad node, which my ad is also typed. It also has, pretty flexible semantics. It can be
yeah,
interfloat. Um, but then that goes directly to just machine code,
you,
like bytes.
you register allocate.
And,
Yeah, you register allocate
like,
this
yeah,
bottom guy. You register allocate
yeah,
my ideal version.
and even then, like the way I do register allocation currently doesn't actually affect the instructions. It just creates an additional table. Like I take my I have a notion of variables because I don't
Yeah,
currently have nodes point directly to other nodes, and so I just create an assignment of variables to different locations. And
yeah.
it's free to like the register allocator is free to introduce new variables and stuff like that. Um,
I
but
don't
yeah, so
put
like
the allocation on the nodes. The allocation's in a side table.
okay, then yeah, same thing.
Same thing.
Um,
Yeah.
But yeah, so like, I'll lower like an ad directly, and that leads to just all these problems because it's possible that register allocation or like, like the nice thing about this is that all of my different register allocators feed into the same place. So even if I do like O0 like stack allocation for everything,
Mm,
it at least feeds into the same lowering code. And so that is kind of a nice bit of reuse I get. But the problem is that means that every single node is responsible for, oh, both of my input variables got spilled to the stack. I need to now like emergency get some registers for that. And
right.
like it it's not as bad as like, oh well I dynamically like push and pop some stuff to free up a register, but I end up conservatively reserving a lot of registers just for scratches. And then I found
Ah,
recently that my scratch code is broken. And so I've been weighing like, oh, should I actually fix these bugs or should I just actually rewrite everything? So
yeah.
um
Yep.
I think my conclusion is that basically you have, the like doing instruction selection first seems like just kind of unambiguously maybe the right answer in hindsight. Like I
Yeah.
should probably just be doing what you're doing. Because, then it also becomes really simple to do any of your I don't know, strength reduction optimizations over
There's,
your like lowered code, right?
yeah.
Um,
Yeah. The lowered code is just nodes. So other things, I don't do optimizations so much on the lowered nodes directly, but because they are just nodes, all my standard node utilities just work. So like global code motion here and the scheduler and the regalloc, they walk the nodes. They print. I have debug prints and dumps everywhere. That's all just normal nodes. So I don't have anything special to make them do things with nodes. I'm looking for a obvious place where I do things with nodes, but I'm at the top level driver. He doesn't have a lot of
I
things.
mean, it's like even if you're not currently doing this optimization, it would be pretty
Yeah,
easy to add like, or I guess kind of it seems like the way you usually do this stuff is you fuse it with other passes. And so like if you're trying to recognize some pattern of like, addressing math or something, you
yeah,
could just do that by looking at your data flow graph. And if you wanted to add like a more sophisticated like tree matching pass that ran until fixed point or something, I don't know if you have to do that. But if you wanted to, like you could do that very easily. Whereas like if you do this later, I think when you get late enough, right, it becomes
yeah.
really hard to actually do that matching when you're actually dealing with, like if you do it after register allocation, you need to make sure you're not messing up any of your implicit constraints on registers.
Because the register constraints. Yeah, no, I do selection before register allocation in a
So
big
yeah.
way because that's a big part of it. The other part for me was that the graph coloring guy does a good job, and he's really flexible, so he can take weird x86 constraints that have been slowly removed over time, so they don't really exist much anymore. But certainly when C2 first came out, he had weird register constraints. And C2 is all good for that.
Yeah, I mean, there's still definitely a couple. I think there's even like one or two in ARM. Like,
I know a
I mean,
bunch in ARM, yeah.
I always think
Stupidly.
of like Division, Sucks 96. I think like
Yeah, yeah,
Shifts.
yeah. So let's see here.
Um,
Let me go
on ARM, I
find.
remember there's like one of them that's dubiously in the same category, which is like there's some SIMD op that requires, I think, like Q29 and Q30 as its arguments or something. But that's like
Yeah.
super niche and probably
Okay,
doesn't
so
really come up
here
anyway.
is div. He has override outreg map, return RA mask, and kill map RD mask, right? And the inputs have RA mask or whatever div mask is. So if your argument number one, you're in RAX. And if your argument number two, you're whatever div mask is, right?
Mhm.
Div mask back. But whatever. It just means all the normal register destinations minus racks minus RDX. But yeah, so I have weird custom reg masks for a handful of x86 ops. And that's exactly where they go, is right in the machine specific guy. And he knows something about them. Like if I go look at the add immediate, he has no outreg kill map or anything, right? He has encoding,
Mhm.
and he has some of the encoding overrides that do let me share the immediate, like he does much of his encoding using the immediate x86 form, which is where you get super encoding unless you know that you're increment or dink. So he has special inkdink super encoding, which will pull up these two bits so he can share the immediate encoding with subtract I, comp I, mul I, blah, 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 all the whatever immediate versions are. But this guy has reg maps, and that's his special. Well, now that you've said that, we could go out this way here. The floats all get overridden. Oh, there's a bunch of them. No, more than I thought for sure. Mem add has no outputs because he's adding into memory directly. The floats all got a thing. Multiply is special. Negate is, why is negate special?
Do you do anything fun with like in terms of x86 specific optimizations? Like if you have a mem add, do you
Yeah.
have any like, optimization step where like I don't know, if you had to do a spill or something, like can you actually
Not
recognize that and turn that into a mem add
not for a spill, but I do things with the
or other
horrific,
stuff?
where's it go? Immediate things. Yeah, this whole piece here, this address piece here does something horrific where he's trying to decide he can use a Leah or not.
Hmm. Yeah, that makes sense.
So store here, here's the add. This is an add. So if you have an op, if your store value is itself an add, and I can find the load and it's nearby, then I'll do an add to memory. I don't do very many of those. I know you can do a lot of things to memory, but I'm not trying very hard here. No, I don't
Yeah,
have
which
any
I
more
think
of
is
those.
fair. My approach so
That would
far
be
has just
good.
been like, I want to have at least like kind of a shared macro assembler interface between platforms. I mean, I guess I might want to reevaluate that if I start moving towards platform-specific instructions, but so far things are pretty portable. But,
Oh,
as part of that, everything is specified in terms of a, like basically just registers in, registers out interface, which has mostly been fine. But, I noticed specifically on like, -0 or something, like Clang will still do a lot of like, you know, good instruction selection on a x86. So even if literally everything goes on the stack, it'll like,
ah,
generate better code. Um,
right.
and that ends up being like, actually like pretty good for its performance. But
Yeah,
it's
yeah.
like O0 performance, so it doesn't matter. I'm pretty dubious that it matters in practice. But
Well, okay. The lesson for me in Hotspot and Java here is that I can both have debug code and full optimization at the same time. I can have full debugging and full optimization at the same time.
mhm.
Uh, the trick for that is to be able to flip between a fast and a slow version of things periodically. You don't have to do every instruction, but every now and then you have a safe point where you can flip from fast code to slow code. And then slow code just does bytecode by bytecode, and the debugger does bytecode by bytecode. Yep. Okay, when are you back? Okay, fine. Okay, have fun.
Um, in a JIT, that makes sense. I mean, we did similar stuff on in JavaScript core. I think if the moment you pulled up a debugger, it would bail out to the baseline JIT.
You could do this
But
ahead of time.
yeah, but then you'd
Well,
I guess it would actually be fine. You're
you have
generating like double the
two execution
functions, right?
strategies, right? And ways to toggle between them. One's debuggable and
Yeah.
one's fast.
I mean, I'm thinking like it's going to result in a giant binary, but if you're doing a debug build anyway, you're going to get a giant binary. So maybe that's fine. It could be interesting to play around with.
Yeah, I also claim that the debug info is big, but is not as big as what I see come out of C++ debug infos. Like Hotspot has debug info, and there's a lot of it, and it's kind of big, but it's not. It's an order of magnitude less than what I see out of C++.
Oh yeah, I mean, well, like if you have a custom debugger, you have a lot more knobs to play with. I'm thinking more like I aspirationally I want to be able to support like GDB or something, and
Right.
I'm
Yeah.
predominantly ahead of time compiled, and so it's like that kind of makes that decision for me, and that I'm just gonna have to learn how dwarf works,
I'm
which I
about to
think
say
sucks.
skip the dwarf and go to a language server.
Can you do like good debugging? Well, I mean, okay, like I'm assuming GDB doesn't work with that,
No,
which I don't
GDB
know.
takes he has a language, he has a, God, well, there's a protocol name for it. There's a GDB remote protocol name. And as
Oh,
far as I
maybe.
know, he doesn't use dwarf in that mode. He takes whatever debugging you tell him over the wire. I could
That
be
might be
wrong.
worth doing. I think I mean there's a lot of reasons to have dwarfs still, but it might be such a pain that it's even those reasons make it not worth it. Like
Yeah,
I just,
right.
generally my understanding is dwarf kind of sucks to implement, so
Yes,
we'll
that's
see.
my understanding as well. I'm hypothesizing that it's possible that I could do decent debugging with this two layout formats. Like I already have the full idealized IR in the ELF file, and they're not that huge. Um, and then turn that into a execution strategy, like horribly an evaluator, which I have already, but not so horribly just a version of CodeGen which has uh, semantic points, C points, Java safe points everywhere uh, that you're just using when you're in debug mode. And that would be my go-to strat. So you'd have a debug version, just the binary got bigger. But now you can always stop in the debugger and single step yourself along. Ben's asking, how can you only increment on the A register? Yeah, you can increment individual. Inkdent works on a lot of registers, Ben. What are you asking?
Oh no, it wasn't a question. Back in the day, the old 8080, you could only increment on the A register.
Yeah, yeah. They found holes in the encoding. You can do more of those. No, that's here it goes. Add immediate guy. His encoding is, yeah, his encoding is generic. He's not restricted. Not anymore. And in fact,
Yeah,
I'm
it
doing
hasn't been
the,
for decades.
yes.
I think I think implicit operands are still restricted. So if you want to have an instruction without explicit operand, then you are gonna be constrained.
You mean like
Just ink, just instruction ink without any register operand. I think that is still constrained to be operating on the accumulator, if I recall.
okay. Yeah, okay. I know that like the byte short versions are restricted. You can't do, there's some limitations there that are odd, as if you want to increment a byte in a byte register. I guess you did in legacy code. Fine. Well, that's my simple state of the simple art.
I guess I have a question. So, um, yeah, so the instruction selection, like, why is that part of the machine and it's not like
Yeah.
a separate like code generation thing? Or is
Oh,
it, I mean,
it's in code generation. It's a code generation phase. It's machine
okay.
specific. The guy stops and looks at the machine he's told to go generate code for. So, okay, so every time I turn it on and off sharing, Zoom grabs the mouse here. Let's go find select. So right here I say try class for name, class file name, get declared constructor, blah, 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 new instance. Okay. If that works, I got an instance of a machine. That's the generic right there for the machine, which gives me whether I'm talking about an x86 or RISC or an ARM. Is that
Yeah,
heading?
okay. I mean, no, what I was tripped up by was it was like in the like node CPUs directory and
Yeah.
not in the cogen directory.
Oh, I see. It's because it's most of it is nodes. So top level, Cogen has all kinds of things in here like Cogen and compilation units and ELF readers and writers and encoding things and global code motion and a bunch of register allocator things, register mask, blah, blah, blah. Okay, so that's Cogen and sensible things. But now when I go look at the nodes, the machine itself, I have this giant pile of nodes. So I pick a dude here, I get this giant pile of nodes out of the specific versions. And then I went ahead and put the machine generic guy, the machine guy who's an instance of a machine, and he does all the instruction selection. He has that big jump table where he takes the ideal and goes to the other guy. It's in here because all the nodes are in here, and the nodes have the encoding. So I threw the encodings, next to them. That he has all the shared encoding logic. How do you implement a jump? How do you implement a this? How do you do immediate 12 and immediate 20? Blah 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 blah. So there's a lot of
Yeah,
those.
I don't know. I mean, to me, I want to keep like the intermediate representation kind of machine independent, and then you're like sticking in all these like machine dependent nodes that
Yeah, so
encode
this
things I
is
would think of as code generation, is I
right,
guess.
right. This is the long history from C2 says that it's incredibly convenient to have these machine nodes be nodes because I have a giant pile of utilities for manipulating nodes, for pretty printing them, for laying them out in reverse post order, for laying out loop nest steps, and every other possible thing you can think of with nodes is already there. So I want my machine nodes to be nodes again. Now, whether or not you want them in the directory under nodes, right? What do you want them in the CPU's directory? That CPU's directory could be under CodeGen. Um, I just figured most of the work was nodes, so I threw it in with nodes.
Yeah, because like I don't know. I mean, the approach I took was I said, "Oh, well, we should just find this abstract set of operations that sort of covers all the interesting machine operations we would want to generate."
Right.
And then so you generate and so you don't have like machine specific nodes, you have like machine specific operations that are like in the nodes, but they're not really actually machine specific. They're like they have semantics that are independent of the machine.
Like if I go look at like div node,
Yeah.
no good reason other than it's fairly unique for everybody. No, nothing special happens with the div node. It does some machine specific things, which are very generic. I divide by constants. Sorry,
Mhm.
machine independent things. Then when I go to the
Right. And so
machine,
I saw it. You're like encoding sort of like the operational types and sort of and like a few things like that in the node.
the
And I
plain
guess I
node,
would be
right?
like, well, why didn't you start with encoding those? And why do you have to make them machine specific? Because like
Ah,
I don't know. I mean, I haven't looked, but I'd
no.
imagine you're kind of duplicating a lot of the like machine specific node logic between like say the
Wait,
ARM and the
It,
RISC-V
is
nodes.
is that even legal? Like, could you multiply it by 1/n? Wouldn't that change the result of the floating point operation in some
you make your
cases, like the rounding?
semantics whatever your optimizer semantics whatever you want, right? So this one here is I'm a float and I'm doing a divide by a float. Now, is floating point associative? Is it commutative? Is it this? Is it that? That's semantics of your language. Is that what you're asking, Ryan? This is separate from Alan's question.
Yeah, I was just looking at that. I'm like, That's going to change the result, isn't it? It's
Yeah,
going to make
yeah,
your.
yeah. Because the floating point is not sort of perfectly injectable or bijectable.
Yeah, you do not do this in LLVM unconditionally for what it's
Yeah,
worth. In LLVM, you have a specific attribute on the instruction that allows you to have things like approximate or reciprocal rewrite.
yeah.
So you wouldn't do this people unconditionally.
In Java, that's the strict FP flag, which gets put on individual nodes in C2 because you inline them, and so you can't take the global flag since you have to take the local flag. So yes, another version of simple, which is a little more complete, would have the check in here that says and not strict or whatever, not strict, right? He would have something that says,
Shouldn't strict be the default though? Because like the
but it
floating
doesn't.
point
Oops.
optimizations make game
It
programming really
it
hard.
it doesn't. It doesn't matter what the default is as long as everyone agrees they understand and they can change it easily. Now, having said that, I've been in both these two different worlds where some HPC folks desperately want strict to be the default, which Java went with. And I've been in a gaming community which is like, oh, fucking lower bits. No one sees them anyhow. Make me go fast.
Oh, actually, in modern games, I think it's the opposite way around, where they're like, "Oh, now our network code is like non-reproducible in multiplayer," and so like now there's a huge push towards
Okay.
determinism and floating point.
Could
Well,
be.
it just depends on which part of the game engine you're talking about. The
Yeah.
physics simulator and the actual game engine, yes, but the graphics renderer, who cares?
There you
And
go.
one might imagine that the simple language is unlikely to be used for either of these. So it's probably fine to do whatever.
Not yet, not anytime soon. Okay, but let me go back to Alan's question. What were
If
you
if
connecting?
Cameron was here, he would of course tell us we should use decimal floating point.
Boy, Matt, your sound quality was bad. I got you made a joke about first decimal point, and I didn't hear the rest. You could throw it in chat for sure. Oh, but chat's been
Yeah,
busy, and I
so
haven't looked at chat.
but I mean to go back to like, you look at this like one of the machine nodes like div
Yeah,
I
let's
don't know.
right. I did this so we could go back to the machine specific version of div with very few other things going on here.
Yeah.
Div. Okay, here's the machine specific div.
Yeah, and so I mean I look at that and to me it's like, well, in LLVM this whole file is like a line in a table and it specifies the
Right.
registers and stuff. I mean,
So what
I'm
is
not
the
sure how they handle the encoding because that's a
well,
little
right. So,
harder,
so
but
this is not a
yeah.
line in anyone's table. That's a bit
Yeah.
more. This
Yeah,
is
that's like a case in a switch statement probably. But
it's more complicated on x86. So I claim there's something, but you can fold it up maybe. Somewhere in the world there's a thing here. I do a lot of this sharing in a lot of the other ones, and whereas div is a little weird. Then I have a one line for the print, which has a few things like it has the slash. So when I do the assembler print, it will print a slash by the registers. AX slash DX will be printed in the registers. Um,
Is your
yeah,
question, Ellen, why you wouldn't like, is it
well,
why you wouldn't have a general div node like across the board across all architectures, or is it why you wouldn't like start with div x86 from like the get-go?
I mean, I guess, it's sort of the design of the code generator is that it's like sort of mixed up with all of the node architecture and then it like translates things to these machine nodes, I guess.
yes. So I'm coming to bin. I can pretty print this as assembly bin, and you will get exactly sort of
Oh no, so
best equal
in
source
C, the
divided by.
assembly block where you specify the register that you're
Yeah,
using,
yeah,
the things that you're clobbering, like the memory addresses or all memory or whatever, all of that information is just encoded in your classes. And then each of those
yeah.
become a node. And then it's exactly the same, whatever LLVM does with those abstract assembly blocks. That's how yeah, it's the same thing.
I'm getting, yeah, okay. I'm getting something very similar to what an inline assembler would write in C code.
Yeah, and I don't know. I mean, I guess the
Well,
question is like, why specifically you did this way, and you already answered that, which is that it's how C2 did it.
no, but why did C2 do it this way? And the answer was I had done portable compilers for a long time. And there was always a lot of things. So you said it's a line in a table. It's almost surely a dozen lines in a dozen tables, not one line in one table. There's too much information here to pack it in that way. So, or it's a plenty of if cases saying that div on x86 is special because the register masks are effed up, right? They're weird. So you get all these custom special cases, which I fought with in prior multi-target backends in several prior jobs. I worked at different companies that were doing chip generations for DSPs of every flavor. And so every DSP knew to do the backend. The backends were all different and weird, and they all had special cases. Okay, so how can I get rid of my special cases as much as possible? What is the minimum amount of stuff I need to make it that I have sort of contained the special cases in one place? And that's what I came up with here. This is the C2 design, but the C2 design itself came from me fighting other people's versions of how you wrote a series of targeted, a portable backend that targets many different chips. Um, I need some way to say, here are the masks in and out and kills. I need an encoding. I wanted a pretty printer that was sort of new for me and simple here. The one that made a much more readable assembly, which is very helpful when you're diagnosing your broken machine code output. Um, that's kind of all I have in these guys. So you
Yeah, I
you
mean,
get the
I
boiler.
guess, the what I'm thinking about is like the way I would design it is I would start with like a pure div operation without, the register maps or whatever.
Yeah,
And
that's
instead
yeah,
of necessarily like converting each node to a specific
that's this guy. This is the pure div guy.
machine concrete node,
Yeah.
which actually it's like to me it sort of duplicates the information because like I have to like it looks like you're like wrapping the node in this machine
I'm
information.
not wrapping it. There's a replacement step. This
It's actually
is
kind of the opposite of wrapping.
yeah,
I think one way that I think about this is that if you think about like your abstract div node, that's like a super node. It's a node that doesn't necessarily exist, right? Like the ability to like have some abstract computation where you're doing any division between integer or float or something, and you don't
yeah,
care about the locations of the arguments. That is always going to be a superset, maybe not a strict superset, but a superset of the like machine capabilities.
yeah,
And so, like something like a div x86 or like I think like a Leah like is kind of
yeah,
a good one. Like
definitely.
these are other arithmetic nodes that even independent of like register allocation are distinct like specific capabilities of your machine. And they're generally like a subset of the things you can encode with other nodes. And so like this lowering step is like you're converting the arithmetic that you can do in abstract general land into
Right.
arithmetic you can actually do in your on your silicon. And the benefit of actually encoding this into your IR is that you can actually then, use your IR structure to then traverse these novel arithmetic instructions. Like there are certain transformations that it might not be safe to do or may not be correct to do on a general purpose, like add or
Right.
multiply or something. But once you know it's specifically like a Leah that's, some add end and then you're multiplying by 8 or something, there's probably some other like, there might be some other optimization you can do where you recognize that's being used in multiple places or next to some other arithmetic or something.
Yeah,
Um,
I'm trying to come up with the math that gives me a Leah here. Oh,
and of course, you could, like you could also do the thing that I described earlier, which is what I do currently in my IR, which is you have actually always the most general instructions all the way to the very end. And I go directly from a generic div that just takes some variables and it returns another variable and it does some arithmetic, and I take that all the way directly to assembly. I never actually do this lowering step. And the problem is like that has been the source of a bajillion issues for me because if you don't make it a little bit clearer, like when you're doing these lowering steps and give your compiler the opportunity to like think about that, then you basically do all this lowering all at once and you have to be really conservative. because by the time you actually get to the lowering that you have to do to generate your assembly, you no longer have a lot of the information that you had earlier in your compilation pipeline.
Yes.
You no longer have the ability to like introspect on it or optimize things or
Yeah.
know when a fast path is possible. So like I end up reserving a bunch of registers and I emit code that like I can't common subexpression eliminate, code when I'm lowering these, instructions. Like there's a lot of stuff that I do that's like, I might just do some I would do some like pointer arithmetic with some pointer and some index or something. And that might show up in like a bunch of nodes one after another, but because it's done too late, I just can't combine any of
You
those.
can't clean it up. Yeah. Yeah.
Yeah. And so, there's a big benefit to doing this a little earlier in the pipeline. And doing it earlier in the pipeline when you still have your IR graph requires encoding this in your IR graph.
Yeah. I don't
I
know
mean,
what this
I
one.
look at this though. I mean, see, I was, doing research on this like 3 years ago, and it was like, oh, how do you do instruction selection? And like, Google's answer was, oh, you use a bottom-up rewrite generator. So I was like, oh, well, that's what I should use then, obviously, So I'm
No,
like, well, why is he not using a
I'm not,
bottom-up
because
rewrite generator?
the learning from C2 was that the bottom-up rewriter was a pain in the butt and it didn't give you any performance gain to speak of. So I went for the easier answer, which is just greedy, which I didn't show at all. Like you guys didn't see the algorithm for the thing, but it's just fucking greedy. It's the obvious greedy. Okay. I did it that way instead of bottom-up rewriting because theoretically it's better if all the world were 1980s Vaxes, bottom-up rewriting would be the thing. They're not. We're all RISCs. All instructions are almost, except for x86, almost all of them have a handful of forms. They're load, reg plus offset, reg plus reg. There's not very many choices in these things. And so the fancy bottom-up rewriter is just a pain in the neck for essentially the same instruction selection you're going to get with greedy. So I just went greedy.
What's a
One other
bottom-up
thing.
rewriter?
Say again? 3 people talk.
I said, what is a bottom-up rewriter? This is not a
Oh,
term I've heard.
BERS, bottom-up rewriting systems. This is what C2 does. It takes
I mean, I get that it's instruction selection.
It's instruction selection. It looks at holistically at a DAG of instructions. So they're sharing at common points within like a single computational unit, which is less than a basic block. And it looks for adding tiling of the instructions, of the machine instructions over the ideal instructions, such that you get a minimum cost tiling. So it uses whatever you call
So this is games like I could do an add and then do a load, but if my load has the capability to do an add in it, I should just do the load and stick the add into the load.
Right. But he gets optimal, whereas I do greedy exactly. I do load with an add. That's one of the things that's in here, and that one is I cover like all the things that the greedy guy gets. Maybe some tiny places where it's a little bit better, except that an x86 of modern format will just all parallel issue all these things anyhow, and it won't make any difference.
The point I wanted to make to Alan is that even if you wanted to do like bottom-up rewriting on these kinds of like target-specific instructions, like say you do lower to everything and then you just like say you're LVM and you do actually want to do your bottom-up rewriting to cover every single case exhaustively, and you are okay spending an astronomical amount of time just like getting quote unquote the perfect code or something. Even if you wanted to do that, you would still need to do that over some sort of structural representation of your hardware instructions, ostensibly. And so if you don't encode that somewhere, which I have to imagine LLVM, like I think they code gen it or something. I'm not
So in LLVM nowadays, you do have global ISL, and that maybe is a bit closer to what Alan wants, because it does actually have an IR that it starts with. It is called generic MIR, which is the generic machine IR instruction level, and that actually just has add node. So it's not going to have a LIA node for x86 or any other target specific nodes, and that's fine, because an add node can lower to LIA, and LIA is just a special kind of add with special kinds of constraints. So you can just add, you can really add constraints, and that's how you get genericity.
But does he pick on for the lid? Does he pick I mean, somebody has to decide he's going to do the shift scaling.
Yeah, that's the actual instruction selection that's going to do this, and that's takes you from the generic MIR to target specific MIR.
So it sounds like LVM also has, indeed 2 IRs and 2 instruction selection
Oh,
phases.
it's a lot more than 2.
Oh, it has a lot more. Yeah,
more,
yeah, yeah,
yeah.
yeah. Because I was just talking about global ISL, but most x86 is still gonna use selection DAC, and at O0 you're actually gonna use fast ISL, which is an entirely different part of code. So you have at least 3 instruction selectors.
Yeah. Which I think there is like a point to be made, like, none of this is an exclusion of doing some other strength reduction or instruction selection on higher level nodes, right? Like there's a lot of optimizations you can do. Probably most of your optimizations you can do at a higher level.
Yeah, I do strength reduction at a higher level. Yeah.
But regardless of that, there tend to be opportunities for further optimization that only really come up once you do your lowering and once you do like maybe even register allocation or something. Otherwise you just have to be a little too conservative.
Here's a funny one. The C2 deals with inserting right barriers. Right barriers want to take a page table, take a pointer, shift it right by 9, and add it to a page table base. The page table base is generally a constant once the VM is up and running. So I want to embed the page table constant. So I generate the page table constant, but the emitting of store barriers happens generally after I've done all other optimizations. And so somewhere late in the pipeline, I explode a store into a sequence of shift, scale, add, store 0 for the right barrier and the normal store. That gives me this giant constant for the page table base as a repeated for every store, and I badly want to CSE it, but I'm past the point where I do CSE, so that one gets like a special case handling. But yeah, as an example of something late in life shows up where you want to do a classic common sub, some classic optimization, but you're past that point in the pipe.
Okay. So I guess I have another question.
Yeah, fire away.
So, I mean, you're kind of storing, I guess, this like register information in the machine nodes.
Yeah.
And it's getting confusing because we have a machine node and we also have a machine class.
Yes.
And so I would question whether like maybe some of the logic there is in the wrong place. Like for me, specifying like the caller save and never save and stuff, that would be part of the nodes calling convention. Like I would say to generate machine code for this node, I have to know what is caller saved and so
Okay,
on.
so caller save specifically is for calls. It's for incoming arguments where there's not a node per se. It's function header node, if you will, and the return on exit. And the other nodes for the reg maps are like a LEA or a div or whatever, single instruction ops. So the callers are not around all single instructions. That's reg map. Calling and caller or save list the argument registers that the allocator has to deal with on incoming and outgoing. So for a call op,
like put it this way, like in the code I've written so far, like my little prototype that I showed off a few weeks ago, the calling convention is like for each instruction.
yeah, that's what regmask is. Regmap is the calling convention for each instruction. So here's
and I don't have a separate like, global calling convention sort of information.
Okay.
It's all stored per node.
When you make a function header and somebody's going to call it, somebody else is going to call the function, how does the function header know what registers which arguments go in?
Well, it looks at the call node and it says, oh, the call node has this calling convention, so I'll generate code that matches that calling convention.
Okay, so a call node, here's I'm looking at call node. He has this calling convention for his reg map, which he just goes to the call and mask thing, which is the giant pile of computed crappy shit that has to happen to deal with how the register allocator names register slots and what the different calling conventions like. This is like Windows versus System 5 and all that.
Right. So you have like C calling convention here, and I have like a general calling convention struct that stores things like calling save and never save and so on.
Okay, that's exactly what the call or save thing is.
All right.
I think
but it's stored on the machine
sounds like
class. It's not stored on the calling convention of the node.
what it sounds like is you have a general purpose calling convention notion. And so even for something like an x86 add or div, you would have a calling convention for those that specifies the registers, and you just reuse the same struct for both. Which I
Yeah,
think,
yeah.
that sounds fine, but I think the like there's nothing wrong with that per se. I think the main thing is it's just kind of extremely unnecessary because for calls, you have to do all this really sophisticated stuff to actually do the like C calling convention for like all
Yeah.
these different types of arguments.
Argument
For
shuffling
every
is
other
terrible.
instruction, you basically only have like very limited, if any, register constraints, like across basically any architecture. So, and so then it turns into like the fact that just being able to, for example, have a reg mask instead of like I guess here like a C calling convention call is also a reg mask. But like for example, in my compiler, like a call is not a reg mask because it needs to handle passing aggregates on the stack. And so that
Right.
needs to be like there's additional information, right? And like theoretically
Yeah.
you could use the reg mask in conjunction with some other stuff, and
I'm not doing aggregates, but I am certainly allowing you to pass many arguments and they will get pushed onto the stack. And one of my test cases is pass 30 arguments to a call and catch them on the other side and do something.
yeah,
Um,
yeah.
so you get
I
stack
think
things. So,
I
so
think
that,
aggregates,
that's
let,
like
let me,
when I lower an aggregate, there's a couple weird cases, like you need to make sure that like a pair of registers store the same value,
yeah.
but it's a little bit like like I can build a
Okay.
reg mask out of that. But I think the point is just you want to use simpler tools in cases where the behavior is simpler, right? Like if you can get away with just like, oh well, for every instruction except for call, the behavior is entirely encapsulated by just a single 64-bit mask or a bit set of like what registers are allowed, then it's like, yeah, that saves a lot of room. It makes your compiler simpler. It's easier to reason about. You don't
I,
need a
I
full
want to
calling convention for every instruction.
I want to also point out that what I hear Alan say, calling convention on every node, in my head, it turns into this like a jargon naming problem. What you call calling convention on a node, I'm calling the register map, and it's the same concept. Separately, I have another concept which is specific to call instructions and function headers that get called, where the register layout is complicated. It varies by calling convention, which varies per function call because I call native code and I call simple code, and they have different conventions. So there's a bunch of games played specifically around function headers and calls that are complicated and fancy, and I give them the name call or save, calling save. And then I don't use
Okay,
call or
and
callee save on normal nodes, but I have the same concept in the register map.
okay, to make
yeah.
this more concrete, so I'm not getting confused on the names, this is things like you just did a multiply, and that multiply is going to set the overflow bit.
Yeah.
Do I need to check that on the next instruction? No, but I do need to make sure I don't do any instructions that will also set the overflow bit before I check it.
Overflow bit's a little funny. I just claim that I'm not going to use it, so I kill it. So if I look at multiply,
Okay.
he'll say, I kill the flags. And then I don't get to look at the overflow bit.
Don't you need to check the overflow register to know if you overflew?
The semantics of
Both?
multiply don't include any overflow. That's the normal
Okay.
semantics for C, C++, and Java. There are special ABI calls or whatever math calls that will get you the overflow bits for a long multiply that overflows. But the normal multiply guy just throws away the higher bits. No one checks nothing. Maybe you want a different example for what you're trying to talk about here, as overflow is, that falls in the camp of two's complement overflow. If I add one to a very large int and it wraps, no one does nothing on almost any language. Some languages do, but most do not.
That's more wraparound. I'm gonna be a pedantic here and correct the terminology that wraparound is wraparound. That's what tools complement does in unsigned C standard. Overflow is the undefined behavior. These are
Oh,
not the same things.
I see. I see. All
I
right.
sat in long committee meeting about this.
Oh God. Okay, fine.
So a lot of architectures have a magic register that's like, this isn't a real register. You can't ever set it. All you can ever do is read from it, and it's the overflow bit as
Yeah,
its own.
flags on
Perfect.
x86. Yeah, a lot of them have flags. ARM has flags. RISC does
I
not have
am
flags, but a lot of chips
I
have
am
flags.
often surprised that C didn't cargo cult that in and
Oh, I
make a
see.
special C symbol that was like,
Somebody
you have the
decided it
overflow
really
bit set
was.
right now.
machine specific, and the C to have any hope of portability could not encode flags in.
I
PowerPC has
suppose that's
4 copies
fair.
of the flags, and you specify which of the 4 flags you're outputting to.
One thing I think when it comes to flags is yes, theoretically that information can be used,
Yeah.
but it's kind of rare that you actually have situations where it would meaningfully affect your code gen. And then having, all of these implicit data dependencies between all of your instructions that read or write flags is probably worse in terms of
Yeah.
the freedom of your backend to optimize.
Yeah.
I mean, if you're the super smart, we're going to spend an astronomical amount of time optimizing our code LLVM compiler, then probably you think about this. But a lot of
I have to
compilers
deal
get
with
by
it on my
sacrificing very
x86.
little.
I have to deal with it on my x86 between comps and jumps. I can't have a kill. Like the comp and the jump don't, they could float apart and you get a kill in the middle and then it kills the flags from the comp.
That's
And
kind of
so,
interesting. Like, is there a reason you chose not to just fuse them? I usually just fuse them. I just always emit a comp and then a jump.
in the misty past, I've gone both ways. Currently, I force it with in the local schedule and registrar allocator so that I can have them separate in the code generation. The instruction selection side can keep them separate. But the registrar allocator and the local scheduler conspire to keep them adjacent. That is, if they start adjacent, the local scheduler always forces them adjacent. If some spill code accidentally gets in between the two, their allocator recognizes the comp got spilled because the flags are getting killed, and he rematerializes the comp next to them. So you could argue that I should have shoved them together.
Yeah, it
I
makes me
mean, I mean
wonder. I've
both.
seen
I mean
some crypto
both approaches
libraries.
work.
I've seen crypto libraries that use big nums in them,
yeah,
and they tend to make the big nums out of 30 to do 32-bit math using 64-bit registers
right.
and
Oh,
just only use the 32 for the big num math
right.
because they can see
See,
the overflow because it's a 64-bit register. They can just look at the next bit.
C2 has this long, strange history around that one, where the
I'm
original
now
x86.
wondering if crypto libraries are doing that because they get better portability than if they had tried to actually check the overflow data on
I
64-bit
I wouldn't
registers.
I wouldn't be surprised there's history there because the x86 got the 64-bit version some time ago, but many crypto libraries would have started life predating them. And then
Yeah.
232s and carry propagate and overflow math. Well, okay, let me get specific. For big
And the crypto
integers
guys don't like to
specifically,
change anything if they don't have to. Like,
yeah, right. Let's go specifically for crypto and big integer though. The implementation of Java for big integer and actually in many languages, because it's the obvious thing to do, does things with half-sized ints where the upper and lower halves carry the overflow naturally because your normal math will carry into it, but you can deal with the upper and the lower half separately with loads and stores and shift by 32s left and right. Okay. In that model of the universe, for how crypto uses big integer, it is commonly the case that you have not too big a big integer, and a lot of the overflow things do exactly what you want for 32 bits, so that if you did 64-bit math and you just slapped the two halves in two different registers, you would either have the high or the low half, or you'd store the low or store the high half, or load from, or whatever, or just refer to one instead of shift by 32, and you actually get better code gen. You skip the shift by 32s because the other high half is where you wanted it for writing it to memory or loading it or whatever.
because high and low are just target registers.
Yeah, yeah. So there is this game played because of how big integer interacts with how crypto uses it that you frequently, it actually works pretty damn well to do 232 bits with overflow to the 64, plus all the shitty math you do to make the carries and stuff go around. C2 has a bunch of code in there to specifically spot those patterns and turn them into split 32s with an add carry. It generates nice code.
And if big int people are doing stuff like that, then you're kind of free to just ignore the flags because
Yeah, the compiler's taking care of it behind their back and doing a decent job. Now, that's because I got hammered because crypto was using big int and big int was generating suck ass code. And we took a look and said, oh, this is stupid. We can do this. And then poof, it got better.
So, okay, let me talk more about my code. So my thought was like you have a node which does the multiplication, and you have like a node which generates the overflow flag. And those are like, floating in the IR up here. And then you're like, oh, well, I need to generate, code for this. And so then it's like, well, aha, I'll just use the bottom-up rewrite generator and it'll be smart. And it'll like, say, I can easily do this like two sets of complicated computations as one multiply instruction and then a very cheap flag check. And
You are welcome to work with a bottom-up rewriter and see how much you love it and hate it.
okay.
You might be fine for one instance of it and for one machine, for one this and one that. It might be great. I was
Okay.
supporting 6 different machines, and the indirection from the bottom-up rewriter, what did we call it at the time? It was like trying to play the piano with boxing gloves on. That layer of indirection really screws you up.
So it's okay. So it's sort of like it's an abstraction that you didn't want to deal with,
Yeah,
is maybe
yeah,
one way to put it.
yeah.
Okay.
That was the
Oh,
main issue. It was another layer of abstraction that got in the way of everything. You had to reverse every mistake, every bug had to be reversed through the burrs to get back to where it came from.
hmm.
Wasn't worth it. And the code quality improvement wasn't worth it.
Yeah. Yeah, no, and I mean, it's like, how important is like special case in crypto versus having like a generic framework to handle every crypto-like thing.
You
So,
know, crypto is as crypto does. It was a hot thing. It wasn't very hard to special case
well,
it.
it's
And then I
still
didn't have to
hot,
have the
like
most.
I mean, I don't think blockchain or whatever has gone away. I think it's
No,
still very
no, it's
popular.
not. So I think special casing it is a good answer. And
Yeah.
then that removed the need of any sort for me to have a generic flags handling. In the end, I ended up with generic flags handling in C2. There too many people cared about it, and it hit in weird corner cases. So I got rid of all my corner cases by handling it generically, but I handled it by saying the register allocator will rematerialize the flag producer. I think, in fact, in the bitter end, I think on x86, I have a push flags, pop flags if you had to spill the fucking flags. And one compilation in 100,000 would have a flag spill that I didn't otherwise get rid of.
Yeah. But one
One
other note, I have one more note. There's
Yeah.
only three. But so so you're finally getting to implementing the code generator, right? After like chapter 24 or
No, the
25
code
or
generator's been there for a long time. You guys haven't just seen it in action for a long time.
okay. But like before you implemented the code generator, you implemented like this sea of nodes interpreter
Yeah, it's
that
still
just like
there.
walks the node tree and
Yeah.
like calculates things
Yeah.
and outputs the result, right?
Yep. Yep. Yes. And there's many tests it runs every day. Yep.
And like, I mean, would you say that's the right approach is like implement the interpreter before the code generator?
It depends on where you're coming from, what you're targeted, and what your life is like. Um, Having an interpreter lets you check the core idealized IR does end-to-end things like sort, like bubble sort shit, or computes infinite numbers of primes or whatever. You do things with it, and you get trust in your starting point IR. Because by the time you go through the code generator in the end, you add a bunch of other layers. So I went through machine instruction selection, code motion, local scheduling, register allocation, and encodings. And each of these have their own opportunities to insert bugs. So if I start with bug and I get a bug at the end and I'm going backwards, where did the bug come from? Okay, I can cut it in half by saying, well, okay, the ideal thing just ran fine. So now the bug's in the code generator side and not in the optimizer parsing type analysis side.
Mhm. But then there's the thing though, is that, your machine specific IR nodes, it doesn't look like you implemented the interpreter for them.
No, I don't. I have an interpret. Well, that's not true. Hang on, back up. I do. The x86 uses the raw x86 hardware as its interpreter.
Cliff, your website is down.
My website is down. You mean the simple GitHub or the Cliff Click website has been down for a while, and I haven't been bothered because the bastards at God, I can't remember the name now. The web hosting company like effed it up a while ago.
Restart your Raspberry Pi.
Yeah, I need to start my Raspberry Pi and run my web server on it. Yes, it's true. Backing up to Alan's point here. The ARM and RISC, I have an ARM and RISC interpreter. I directly execute ARM instructions in a. It's not Qimu that Matt's always pushing on me. It's just a stupid one Java page, literally one file Java interpreter for ARM and RISC 5 ops, and I run those
Okay,
two.
but like you don't implement like your own. Okay, so you did implement your own like like instruction interpreter that like
For
takes actual
for
machine
ARM and
code.
RISC 5, I have an instruction interpreter. Yes.
Okay.
I'll just bring it up and show you, and I can show you tests that are using it.
Does it collect
And so
metrics so you
like
can
if you
compare the
wanted a more
efficiency of two different backend choices?
Say, let's go, Aaron.
Does your interpreter collect any metrics so that you can compare things? Be like, oh, if I use this optimization, I can solve this problem in this many instructions. But if I use that optimization, it takes more or less.
Um, I mean, no, and it could. I'm counting
It just feels like a
instructions.
place where you could get some A/B testing leverage.
I could. I mean, I could count instructions executed as a proxy for time. I do count instructions executed because I put a max ops here. And if you run out of max ops, I abort the test. And I say for max ops. But then I see that I'm in the execution buffer, and I'm going to align instruction because this is RISC 5, and I load an instruction, which looks like calling a RISC 5 load for signed op. And then I start breaking it apart into the different pieces and deciding what the instruction is. And I have all flavors of instructions and how they break up. And I'm executing RISC 5 ops. And that's the entirety of it here. So it's 370 lines for our RISC 5 evaluator. The ARM one is somewhat bigger.
yeah, but I mean you could just use like QEMU or something for
Yeah,
it.
you could do a QEMU. I didn't say I didn't because I didn't want a deal. But fine.
Yeah. All right.
Okay, so here is anyone or any number of guys that do something, something, something. Somebody made a stack. This is look like this is a chain conditional test. And test RISC 5 build gives me an eval RISC 5, which I then step for 100 steps or until it exits. I see that there is no trap. I grab the RISC 5 A0 register and confirm that it's a 0, and I declare victory on that test. So this compiles this down to RISC 5 ops in a memory pool, throws them into the evaluator's memory space, evaluates them till the program exits, and confirms the output. And repeat same for everywhere I said, test RISC 5. This file has quite a few, but many have others also have quite a few. So that's a common thing since the code generator came around.
I can offer a alternative approach to writing an interpreter. Or at least this is the thing that I used for my backend. Is
Here's
I think
BrainFuck, by the way. Just a second. Sorry to interrupt. BrainFuck
oh yeah, go for it.
runs for 100,000 steps, and he gets a pointer out of the return register A0, which he then confirms has he walks the pointer. He has to do the pointer offset math, and he's loading bytes out of the thing, and he's confirming that it's the characters of BrainFuck, which print hello world using the BrainFuck language as here's the BrainFuck print something stupid. So BrainFuck runs RISC 5. This function gets compiled into RISC 5 and executed in the evaluator. So it's a pretty substantial, I mean, it's a reasonably functioning evaluator.
It's a
All
good
right,
test.
David, go.
I was gonna say, writing an interpreter is definitely like I think a pretty good option, but it does sort of raise the conundrum that you have this surface of like your interpreter implementation that is now separate from your code generator. I think that's definitely doable, but the thing that I did for my backend is basically just support different optimization levels. And so
Mhm.
not quite as abstract as writing an interpreter, but pretty close in terms of like the simplicity and avoiding like some of the other bugs you can get from optimization passes is just having like an O0 optimization level where everything is written to the stack, everything uses like some scratch registers, everything is like as simple as possible. You run no optimization passes and you just directly implement your semantics. Once I got that working, which did not take too long, I think any subsequent bug I was able to just, see if it worked at O0, and if it did, then I would figure that's probably one of my optimization passes.
Right.
And so that's sort of been my baseline that I use for this. I think having some sort of baseline to compare against as you're doing actual optimizations is really important. Um, Using O0, I think I've been pretty happy with that as opposed to an interpreter, just because I think it's still stressing all of the exact same code in terms of like generating assembly and making like legalizing the instructions and stuff like that. But of course, also to get it running, I had to actually go through and make all the assembly and legalize instructions and stuff. So it was maybe a little bit more like work up front.
Then yeah.
Um,
Well,
but greater reuse between the two.
the evaluator, the RISC-V and ARM evaluators were very helpful in sorting out issues with mostly with code gen, occasionally with register allocation. Um, yeah, you need some low end, or it's helpful to have some low end version of things. So the evaluator for me is your O0. It's just a direct sea of nodes evaluator, not terribly efficient. All right. In a minute, I'm going to declare victory and be done. Do you get maybe any other questions here? Okay. So Theodore, who's had to drop, will be running the next two if he can find the time and space. And I will not, there's no way I'll be able to log in on either one of those. I'll be in Burning Man, I'll be off grid. The one where I'm at the company, but that's a month away. I can probably log in on that one. Yeah.
So I did have a maybe another off-topic question here. I was thinking like of basically having a virtual machine that could be like deterministic and also high performance at the same time for like C and C++. Do you think that that is like reasonably doable with like a JIT compiler, or
Depends
am
what
I
you're trying to high performance, virtual
maybe
machine.
like single-threaded high performance that can like we could target like I don't know GCC or whatever.
Single
I assume you're
threaded
not
is
counting execution time as part of your determinism.
Obviously not. Let's just
he's
like the
not,
results.
but the single thread is not versus parallel is not. You can be totally deterministic in parallel. H2O is my old giant math
Well,
cluster
you
computing.
could, but not for like so it wouldn't be something that would be able to like compile GCC to like the bytecode for the VM and then run GCC in a deterministic mode. Like I want something that I can run like actual tools in a way.
Okay. But
Um,
why is it not just take the x86 and run with it? What are you missing for determinism here?
well, I don't know of a deterministic x86 emulator. There's I guess the closest thing we have is QEMU, but that would be really
Right. I'm with
complicated to
Ben
set
here.
up.
Where does your non-determinism come from when you're running any C++ program through GCC directly on the raw x86 hardware? Where is non-determinism coming from? On a single threaded app, where is non-determinism coming from?
Time and also just like
Okay,
different
you already
instruction
said you're throwing away
support,
time.
right? So like multi-threading.
Okay, as soon as you say
Uh,
multi-threading, you're not single-threaded.
right, but I'm saying like the VM could like, even support threads, but it
It,
wouldn't actually like let's say like you could have threads in your VM, but each thread
okay,
executes, a
but
thousand
let's back up.
instructions and
Hang
then
on, back
switches
up.
threads.
I want to clarify a base first. If you are single-threaded and you're ignoring time, do you believe that you will be deterministic on a standard x86, some Linux OS, who cares which one, running through GCC?
Okay, it wouldn't be reproducible though, because like the virtual there's not really like a great
What's not
portable
reproducible?
virtual like if I want to run it on Windows or on Mac or
Okay, so
like
on
I don't know
one
if
platform, if you run it back to back to back, how deterministic are you? Yeah, the hard drive's not deterministic, Ben, but that's not visible outside the OS layer, other than time.
like you might get just the determinism that way, but what I'm worried about there is like um there's hardware acceleration with QEMU, and then also like you know um you may have time exposed, like you could probably get it to
But
work if you like set all the right options correctly.
what I'm saying is first get deterministic on a single machine, on a single program, single language, single compiler, single. Now you start adding things that make life more complicated. Hey, I want to work it across 5 different OS flavors. That's what the Java write once, run anywhere was all about. And there's some work there.
Yeah,
And
I'm
can,
wondering if having like a sandboxing compiler from the start
I
would be
think,
better.
Cliff, I may think that Ryan may want to do something like antithesis does. I don't know if you are familiar with antithesis, but they basically wrote their own deterministic hypervisor, which is
yeah.
actually very helpful for fast testing because now you can have things like reproducible fast testing campaigns. So maybe something like deterministic hypervisor is the answer.
Yeah,
But the,
hypervisor. You need some sort of container.
And it's actually even useful for multi-threading because you can even have a set fixed schedule of the thread execution, so you can deterministically test multi-threaded programs and bugs in them. So there are actually some valid use cases for that.
yeah, that's kind of what my idea was. But like, so I know there's like some deterministic hypervisors, but don't those like require hardware support in general? Like I want something that's like portable across machines and trying to like design a like an instruction set that can basically be optimized as well
Yeah.
as possible.
So I think it would be harder, but for what it's worth, there is actually a crypto subset of ISAs, both for ARM and for Intel, for the so-called data independent operations. The problem for your use case, though, is that those are mostly arithmetic instructions. Like you can guarantee that addition instruction operating on such and such operand always takes this many cycles. You can actually guarantee that, but it's a very small subset. And for general emulation, it could be hard to use that subset alone.
Oh, so I don't care how many cycles something takes. I was saying, like my virtual machine executes
Ah,
exactly 1,000 instructions before switching threads.
I assume you want. Okay, depends on your use cases because in my mind, you wanted to do also things like multi-core testing, and then it's actually useful to have determinism in terms of the exact cycle count because then you can reproduce multi-threading bugs. So it is useful, but it's not trivial, is what I'm saying.
No, my use case is more around I want to have a portable, like I want to be able to create a tool and I want to stick that tool in my like source code or like tools. And then I want that tool to be able to run when anyone builds, but I don't want the tool to be able to like access the host system in any way other than as part of the build. Like it would only be part of the build. It can't like, like put files on the host system. It would only be able to like create intermediate build artifacts. And then I also want that architecture to be as portable, like you would have to run anywhere, basically, like kind of like Java, but I also want it to be deterministic. And then to also get like, how do I do that and also get like decent performance?
Yeah, I think if you want decent
Run
performance, then
inside the
some
JVM.
hardware support would help.
Run inside the JVM inside Cliff's script he just showed.
I don't know that the JVM is gonna like solve this problem because it's the same problem as using LLVM where you have to like sandbox the generated bytecode somehow and then provide determinism from there.
Other than the obvious parallelism you get out of a JVM internally, externally from new threads start, blah, 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 all the bytecodes are deterministic. They all
Well,
run in order, do the same thing.
if you allow native thread, you can't use native threads because native
Yeah.
threads are not deterministic. So you have to have
No. You have to define the points where the native threads interact with each other. Because I totally run
and
with native
I
threads and
understand
get
where you're going
deterministic
with that,
behavior.
but I can't compile GCC to that because it's not expecting to create custom data structures for threads, right? It's
You keep saying compile GCC to, and you're mixing concepts here. Java's threads use native threads, but they are very carefully managed, and you get to control how they talk to each other. And if you do that, if you control how they talk, you can totally have parallelism and non-deterministic when the threads launch, come up, go down, whatever, but get completely deterministic results out of it. And I have a large startup running big system software that does exactly this.
So with the Java case, I like you could run more than one separate process in parallel, but if like a virtual process creates two like virtual threads, I want that to not actually create non-determinism inside the virtual
It
machine.
doesn't.
Like,
No, you don't get to non-determinism from having two threads. You get non-determinism by two threads talking. If they don't talk to each other, there ain't no non-determinism. They just free running and independently do their own thing. You
yeah,
wait till they're both done.
that's complicated because they've got memory that they have shared memory in the C++ land and
Under
like
a good supervisor, so Java's virtual machine manager, you can arrange how they talk. And that is doable, and I have done it in a large industrial way.
I'm just like wondering how to implement. So like how if I create the illusion of seriality, like
Yeah.
okay, each thread is like it executes 1,000 instructions regardless of how many cycles it takes, and then it switches threads.
You're coming at this the wrong way. So I launched two threads. They're independent. They don't talk. They can't see each other. They have no clue. They have no way to interact. Okay, they both free run. I don't care about time, so I wait till they're both done free running. Now I'm going to take communication from them both, and then I can arrange that. I'll pick one ordering as to how I take a read one first and the other. I'm back to being completely deterministic, but in the middle, two things ran in parallel.
Yeah, but
So for me,
that breaks the C++ model because like if I have two C++ threads, right?
I'm
I
not
mean,
I'm not I'm not saying C++. You separate these things out. There are
no, that's the
implementations like
problem.
C++
I can't
that
because I want to be able to compile tools written in C and C++ to run on
okay,
this
now
virtual
now
machine.
you've given up on having Java as the hypervisor controller. You need to do this with somebody else's hypervisor that boxes the C code, and you have to say, Mr. C code, you can't call new thread. I'm just going to turn off P threads.
No, you would be able to, but the pthread would like have to like implementation wise, it would call this
Okay,
VM
then you
instruction
have
that's like
another
new
problem.
thread.
You want to build a hypervisor yourself that will run generic C code in a deterministic way. And now you have the same problem as writing a Java virtual machine, which runs
Essentially.
threads in a way that can be deterministic. You have a big ass job, but maybe that's what you want.
What I was thinking is like the threads wouldn't be actual threads. Like no matter how many virtual threads you create, they're just serialized. There would actually only be one thread. And and I know that that sounds pointless, and it is, but the purpose of allowing you to create threads
Read the
inside the
chat.
VM is like so that code that was written using threads in C would work, not
Okay.
necessarily that it would actually get parallel performance.
Yeah, so slow down here. So go read chat. These things have been around for a while. The reproducible, the RR debugger, whatever there is such a thing where exactly what Ben says, every thread you launched in C got intercepted, launched its own process with its own fault manager for its own shared memory thing, said the pages were watched carefully and you couldn't allow two threads to talk to each other without deciding what the communication meant. And one answer is you crash and say, hey, they're parallel talking without concurrent without they're being non-deterministic, so I'm going to kill it. Another one is I'm just going to fix an ordering, and every time you replay, I'll force that ordering again, and that's another big job. Yeah,
Yeah,
and
I thought
you're
about the crashing thing. It sounds really expensive in a couple of ways. Like one is,
not expensive. It just ends the process. You get no answer.
well, okay, so I have like two threads like accessing data in that's next to each other. So I have a struct that contains in let's say bool A and bool B. Thread one writes to that bool and then thread two writes to the other bool.
Yeah.
That's not a race in C, right? That's legal because it's a different byte that's being
So
accessed.
so
So
some
now
not all
so
C programs. Not
I
all C
can't use
programs
the
are valid, and if you want to run all valid C programs, then you have to do something really brutal here. Yeah,
I know.
that you could do the
That's my
page
point.
table thing as an efficiency hack, but as soon as one thread writes to a page, another one wants to write, then you get down to sub-page words. You get into words. As long as they don't touch the same word, they didn't communicate. So
So
you could
I
do
was
this.
thinking that would be so much overhead that I'm better off just making it single threaded and say each thread executes 1,000 instructions, then switches threads.
This is your choice on how you make that work. Just saying, there is a way to make concurrency work in general, but maybe not from arbitrary C code without going through giant hoops, which the replay debugger folks have done. Go look up the replay debugger. There's a solid. I think they do almost every possible C thing, and it works, except that there's a big pile of work to make it go.
I mean, the SQL databases basically do that. They record all of the non-deterministic things that happened in their transaction so they can replay the transaction.
Yeah, right.
But that requires a lot of recording stuff that can make the write-ahead
Big
log
engineering pile. Big pile of engineering work. H2O's solution targeted a different problem space, but also is a big pile of engineering work to allow deterministic computation on vast scale. But not every computation, just things that look like bulk synchronous parallel math. All right, so I claim, Ryan, you've picked a job for yourself. Go for it. We eagerly await the result.
I would start to the antithesis guys, because maybe they will have some ideas, at least they have done something similar. It's always a good idea to look at related work if possible.
It is, and I haven't seen this before, but it looks really good. Your antithesis, it looks really good. So more reading for me to do, except I'm going to be packing for Burning Man instead. And I can't take it with me online to Burning Man obnoxiously. Because there are plenty of times when I could read at Burning Man.
What about Starlink?
Oh, somebody has to have it, and they have to let me have it. And it happens. We've
like
had
Starlink is
Starlink in
missing
our
the point
camp
of
on
Burning
and
Man
off.
slightly.
I'm sorry, I don't want to read on my phone. So I want to bring a big laptop that's not going to die in the heat. Sorry, I have wildlife gone crazy in my yard right now. The deer are screwing around with a murder of crows, and there are quail running around. It's just like, what the fuck? Stop, guys. Yeah, I'd have to get
understanding
a
is the
better
problem with
laptop.
laptops tend to be that you'll never get all the sand out less than the heat.
Well, I'll take the ancient laptop. I don't know. I see people do things like you sack it. You put it in a big old plastic Ziploc bag and you zip it, The only thing comes out is like a power cord. And then you have to type and see through the plastic bag. It works great on phones. So we'll put the phones in a hard plastic dust case, and then we'll put them in a plastic baggie. And actually, the phone's really readable, and the touch system all works. And
Did you
when
know that
unpeel
Hummer
it from the
is an
layers,
OEM for laptops that are sand and waterproof?
Yeah, I don't have one. I wasn't going to pay for one. But you can get those.
I think there are very few non-military customers of the Hummer laptop.
Yeah, fine. All right. I'm going to declare victory here. It's well past time. No, it's not well past, but it's time. Very fun. I had a lot of fun, and I'm gone for 2 weeks, and I should come back with quite the tan. And God knows what other things. Memories. I'm going to come back with a ton of experiences. All right. Till we see you guys again in a couple weeks. Bye-bye.
Have fun!